Welcome. In this video, I'm going to explain you the most common mistake during installation of the solar panel. This information I'm going to share with you on behalf of my personal experience. I have installed a lot of uh, solar system on different places. So the first problem is if you have the battery, for example, 24 watt hour, and and if you run the one 1200 watt load, so it should work for 2 hours. But when you use the system, it sometimes it just work for 50 minutes, 40 minutes, or 1 hour. So that is not according to the calculation. So what is the root cause of this problem and how we can solve this? That is the first thing. Later I'll explain this in detail. The second mistake during the installation we make, if you see on the back side of panel, you will find the data sheet type image sticker on the plate, and if you see the maximum current is 6.4, but when you install and after installation you just get 2 or 3 amps, you are not going to get. So how to solve this problem? And the number 3, which charge controller you need to select. MPPT is quite expensive as compared to PWM. So can you use the PWM to get the same performance? Yes or no? I think you can get. So what is the solution for this all these three problems? So let's start from the first one. Okay, here I show you an example image here. For example, if you have the battery of 200 ampere hour and with 12 volt, so you can calculate its total watt hours. That can give you 24 watt hours for single battery. This means 24 watt load can work for 1 hour, and if you use 1200 watt load, it can work for 2 hours. So for example, 1200 watt or theoretically should work for 2 hours, but sometime it just, if you have the new battery, you have the new system, but your battery just give you the backup for 1 hour, 50 minutes, 40 minutes, or in the start if you install the system it may give you 2 hours, but after a few days it suddenly drop to 1 hour or 40 minutes. What is the problem in this case? This is not the problem of your battery. If you have the new battery or if suddenly it drops the time duration, backup time duration. If the backup time duration drops slowly, then you can say the battery life is decreasing. That's why the time is slow. If it suddenly drop or the new battery give you less time, this means your installation has something wrong. So let we discuss the battery charging and discharging voltage. Here I will explain you why you are not going to get the full time backup. So according to, I can say, the international standards, the minimum, mostly UPS inverter companies, what they do, the minimum level voltage cutoff is 10.5 volt and the maximum is 13.7. Some companies use 13.65, some use 7.5. It's almost these values, the minimum and the maximum. So here in whole solar system or UPS installation, the most, and I can say the most important part is here, inverter and battery. Between inverter and battery, this wire, you should make sure this wire has no voltage drop. Using the common method, you cannot find the voltage drop on this wire. So which technique you should use? You should, for example, if I am going to see the battery and inverter first, then I will see the charger, solar charger and battery, these two things. So you need to turn off this charger, you need to turn off the inverter power in, only power in. So you need to turn on the loads, the maximum load that you can, or at least it should be the 70% capacity of your system. So when you turn on, so at that time what will happen, battery will start discharging. So you need to take the multimeter. You should measure the voltage at the terminal of the inverter, and then go again and measure the voltage on the battery terminal. If the difference between these two voltage is greater than 0.5 volt, it means your installation is not correct. If it's less than 0.5, it means your installation is perfect. So why is it like this? Why I'm going to say to do this test, you need to first understand here. Here I say, when your battery is fully discharged, your system start charging from 10.5 and the battery voltage raise up, and when it reads at 13.7, then your battery stop charging. This means your battery is fully charged. So if here now I say you run your load on 70% and you turn off all other things, input voltage you turn off. So if there is the voltage drop, for example, if I say I give the example calculation here, you can see, uh, for example, if your load is 1000 watt and your battery is how much, 12 volt, then the current on this wire would be how much, that is 1000 divided by 12, that is 83 amps. 83 amps is the quite high current. So due to such high current, wire can be heat up. Due to the heat, the temperature coefficient, the resistance of wire may go slightly higher, or it can increase. So here, for example, the resistance of this wire goes to 0.01 ohm. 0.01 ohm is a very small resistance, but in that case the voltage drop in the wire would be how much, 0.8 volt. So you need to see what will be the problem here. If your battery has the voltage, like if I consider the battery voltage is 11.3 volt and zero point 0.8 is drop across the wire, what the voltage inverter will receive? Inverter will receive 11.3 minus, I can write here, 11.3 minus 0.8. That would be equal to how much? 10.5. Because this here, in the start I told you this is the cutoff setting. These are settings in the inverter. So inverter will think that your battery reach at the lower cutoff. It just will turn off the system to show that the battery is empty now. But in fact your battery is not empty. So what will happen? This part of energy you will not be able to use. You invest the money on your battery and everything, but this part you are not going to use just because of this small voltage drop on this wire. So I will explain you how to reduce this voltage drop. So same case, this is the discharging of battery. Same case during the charge. If you have few voltage drop across the wire during the charge, even your battery will not reach at the maximum voltage, but your inverter will read the higher voltage at this end. So it will stop charging. So what will happen? Your battery will not be fully charged. So you are not going to charge your battery 100% and you are not going to discharge your battery fully. So that means you are not going to use the 100% capacity of your battery. So if zero point 0.8 voltage is dropped during charge and discharge, so it means you are just going to use the 50% capacity of your battery. You are losing the 50% capacity that you can use. So here the small mistake can make your system performance 50%. Even you have the good solar panel, good charge controller and have the expensive inverter, you have the good battery, but this small mistake can make your performance 51. How to reduce this? So let's go. And why this problem happens? Number one, if the length between the inverter and battery is long, then the voltage drop would be higher and higher. So you should try to keep this wire length as small as you can, and you should first check the maximum current flow through this wire, and you need to select the cable that can support such high ampere currents. So if your wire can support such high ampere, but again I can tell you, some wires can support high current, but still they have a minor resistance. Due to that resistance, you cannot use your maximum battery capacity. So you should make sure the length between the inverter and battery is small. The same case, I'm not going to explain it again, the same case is with this charger, because this charger only do the charging of battery, and if you have the DC load, it also will do the discharging. It would be same as inverter. So this part of cable should be high quality cable. The length should be as small as you can, and here on the connection you need to make sure the connection are very good. If there are loose connection, that will also give the spark and also will drop the few voltage. Even zero point 0.1 voltage drop can reduce like 5 to 6% of your whole system performance. So that was about the first major problem that I experienced. Many people, they can't find this problem. So again, the final one thing I want to tell you again, you cannot find the voltage drop across this wire if you connect your meter, one cable here and one here. So what you need to do, you need to connect one time, measure the voltage at this point, plus of your meter here and minus with the black wire here, and then for example if you get like 13, and then again you get on measure on the battery when the load is running. Make sure when your load is more than 70, then again measure on the battery, and then you find the difference between the two voltage. That would be the voltage drop. So that was about the first problem. Let's go for the second one. How to get the rated current output from PV. So that is related to the third section, and they both are related. So I will explain you the third one first. So there are two type of charge controller when you install the solar system. Most of people are, they think that MPPT is the best one. I also think that MPPT is the best one, but in some cases, not all cases, sometimes PWM can give you the better performance. This you should know in which case you have to use PWM and in which case you have to use MPPT. If you use MPPT in all cases, your system performance will be the best, but that there is a big price difference between PWM and MPPT. So you should know, if in your case you can use PWM and you can get the same performance as MPPTs, then you don't need to buy MPPT. So I'll give you the three examples, so you can understand three examples, and then you can decide which charge controller is best for you. So before going to explanation, I would like to tell you give you a real example that would be easy for your understanding where you should use MPPT and where you should use PWM charge controller. If you know these some international standard that our electrical grids they use, like you can see here the different standards. The 11 kVA is very common. You can see in your street or in your community they use the 11 kVA, then they use the transformer to convert it to 220 volt and give to the houses. and this 132 kVA and 220 kVA and 400 kVA is the very high voltage. These the grid station they use to transfer the electricity from one country to other country or one province to other province. So that is used for on the long distance transmission. So have you ever think why they use these different voltage, these such high voltage standards? Why they don't use directly 220 from the grid station? If they use directly 220 volts from the grid station, they don't need to use such an expensive transformer or any conversion system. They directly can supply all houses just 220. So why? There is some reason behind this. So if you understand that reason, then you can understand why the MPPT we have to use in which case, not in all cases. So okay, let's go. First thing you need to understand, when we transfer the power from one point to another point, the distance is the important thing. If because the power loss is I square R. Here you can see the resistance of the wire. If you have, for example, 1000 kilometer distance from point 1 to another point 2, so the length of wire will remain same, the resistance of wire will remain same. Here is the current I square R. The current will increase, mean the power loss will increase on the wire. So if we increase the voltage, that means power will remain same but the current will reduce. What we do when we transfer the power from grid station to other province or other countries or other cities, we transfer the whole power at high voltage. When we go to the high voltage, the current goes low. So it's mean during the transmission of power from one country to other country or one province to other province, the power loss goes minimum. When we want to use it, then we again convert the high voltage to low voltage, then it increase the current again and we get the same power and we reduce the power losses. So that was the technique of transferring the power. So now, okay, I take the example one now. Here, for example, here you have the 6 volt each panel. If you connect two panel in series, that would be how much? 12 volt, and you have the 12 volt battery system here. Then two more panel connect in series, that will be 12 volt. So now these two pair we connect in parallel. So how much voltage we get? Here on the charge controller, on this system we show the MPPT. So you can see MPPT is receiving how much? 12 volts. So the battery is how much? 12 volts. So do you need, in fact it's not 12, the panel would be slightly higher than 12 volts. So this is just for your understanding, this is the 12 volt, this panel is for 12 volt battery. So here you can see, do we have to transfer any voltage here? No. So if we don't need to transfer the voltage from high to low, then we don't need to use MPPT. There is no purpose of MPPT. MPPT basically what it do, you give it high voltage at input, it reduce the voltage and increase the current at output. But here we make two pairs connect in parallel. The voltage of one pair is 12 volt and other pair is also 12 volt. And if for example the current is 6 ampere of one pair and other pair is 6, the current will add automatically, it will be 12. So MPPT here don't need to uh, do any function, it directly just need to transfer this power to battery. So here if you use the PWM, the system performance will remain same. You use PWM or MPPT, so where would be the performance difference? So let's go next. Example 2. Here you can see 120 watt 12 volt, 2 in series, it's mean total 24 volt. Here total 12 volt and 12 volt. Two in series, total 24 volt, correct? So MPPT is receiving 24 and it's going to supply the voltage to 24 volt battery system. So here again you don't need to use MPPT. I don't mean you don't need to use, you can use MPPT. But if you use PWM, that would not affect the system performance. In example 3, here, now you see, if you have the 4 panel, all connected in series, each is 17 volt. Then if you connect in series, the voltage will be added, but current will remain same. So this charge controller is receiving 68 volt with 6 ampere, but it's going to charge the 12 volt battery. So what MPPT will do, MPPT will receive, here I can say like 17 into 4, that goes 68 volt. And what would be the receiving power? The MPPT that receive would be 68 into 6 amperes. That would be around 428, like this, 428 watt. But the output is 12 volt. So the MPPT, what should it do? The output current at this battery, it will provide, theoretically I can say, 428 divided by 12 volt battery. So that would be how much? 35 amps. So here what MPPT charger did, it received the power with high voltage at input, and it transfer this power at output with low voltage, but it keeps the power same. It transfer high voltage to low, and low current it transfer to high current. So here at the output you receive 35 amps. But in that case, if you use PWM here, PWM don't transfer the high level current to low and don't change any current. It will directly supply the 6 amps of current. That will reduce your system efficiency. So here you need to decide this configuration is for MPPT. So in which case you need to use this configuration. For example, you are living at ground floor and your solar panel is at first floor, and the wire length is not too high, so it means the transmission distance is low. If the distance is low, then you directly can use this configuration, like you can make some pairs in parallel that directly can add current automatically. You don't need to use MPPT to increase the current. So if you add the panels in parallel, it can increase the current automatically. So this is the one reason, if the distance is small. The other reason, if you don't have the good enough cable that can carry high current. For example, each pair provide the 6 amps, two pairs 12 amps. 12 amps cable you can find easily. If you have more pairs, for example, one, two more, it will go to 24 amperes. So 24 amps cable you also can find. But if you add more and it current goes high, 30, 40, 50 amps, so such a high quality cable, it's might not be possible to find for you. So then what you should do, then you need to add the panel in series and just increase the voltage. the current will remain low at the wire, and then you give that current input to the MPPT. MPPT will reduce the voltage and increase the current to charge your battery. So that is the thing. So sometimes you don't need to use, if you are, for example, if you are using one or two panel only, so in that case PWM is the best one. You don't need to use MPPT. If your system is really big, you are using 10 or 20 or 8 or 9 panel, then you can use MPPT. That can give you the best performance. But if you are just using one or two panel, 150 watt, 300 watt, or up to 400, 500 watt, then PWM, I will say the best one. Okay, so that was about the configuration of solar panel and MPPT and PWM. So I hope you got my point, where you should choose MPPT. The reason one, if the distance a solar panel and your inverter or the battery is long, then you have to use MPPT. And if you don't have the good enough cable, and you are using a lot of high power, lot of solar panels, and for example 1000 watt, 2000, 3000 watt, then you have to use MPPT. So if the wire distance between the inverter and the solar charge controller is less, then you have to use PWM. You can use MPPT, but MPPT is expensive. If you use PWM, in that case you will get the same performance. So if you are using okay, that was about the selection of panel. So here, and that is the second thing that I skip. I can say again here, the rated current if 6.4 ampere and your sun is fully shining. So if you need to measure the current, if you're not getting 6.4 ampere, so then you have to again find the voltage drop near to the panel. Sorry, not voltage drop, you need to measure the voltage near to the solar panel, how much, and then you should measure the voltage at the other end of cable, for example near to the solar charge controller input. So if the voltage drop is higher, is same as in the first case, so it means your cable quality is not good or cable length is too long. So that would be the reason that you are not going to get the high current. So you should improve the connections, you should improve the cable quality, and you should reduce the cable length as you can. So that was all about these three major issues. If you have any questions or comments, you can write in the comment, I'll answer you. That was all about. Thanks for watching.